Assalamualaikum warahmatullahi wabarakatuh. So today I will this video contains about complex number, the introduction of the complex number. So the first thing you have to know is what is complex number. So a complex number is a combination of real number and imaginary number as below. Z is equal to A plus BI. So Z is the notation for complex number. So you already know what is real number. So imaginary number. Okay, sorry. Imaginary number is I. Okay, the notation is I. So it is equal to square root of -1. Okay, and I square is equal to -1. Alright. So complex number can be plotted in Argand diagram as below. Alright, so you can see where is the imaginary number. Oh, imaginary number in this part. So real number, okay, and then real number in this part. Okay, this one is the imaginary number. So below are the example of complex number. 1 plus I, square root of 3 minus 2I, -7I, and 4 minus 5I. Okay, so it has negative, it has the real value and real number and the imaginary number. So that is why we call it as complex number. Okay, so the first example is solve x square minus 64 is equal to 0. So we know that x square is equal to uh, so I think that you have to there is correction here. There is it is x square plus 64 is equal to 0. So x square is equal to negative 64, and then x is equal to square root of negative 64. Okay, so we know that we can separate it into square root of -1 times square root of 64. Okay, so this one we know that the square root of -1 is equal to I, and then square root of 64 is equal to 8. Okay, and then the final answer is 8I. Okay, the next part is a complex conjugate. Okay, let Z is equal to A plus BI and be any complex number, then its complex conjugate is Z bar is defined by Z bar is equal to A plus BI. Sorry, A minus BI. Okay, in other words, a conjugate is the change assigned in an imaginary part. Okay, properties of complex number. Okay, so the conjugate is actually the change of sign in imaginary part. Okay, properties of complex number. So the first one is addition. A plus BI plus C plus DI is equal to A plus C plus B plus D times I. Okay, maksudnya kat sini kan, okay, the first part, okay, this is the complex number. Okay, and then we add with the also complex number. Okay, but we know that every complex number has a real number. So the real number, we just add it together here. And then the imaginary part, okay, we have to add it together. This one. Okay, example 2. Okay, this is example that applies the addition concept. So the first one is 2i plus 5 plus 2i, and then how to solve it. Okay, so this is the real number part. And then this okay, and this part is the imaginary part. So 2 plus 5 plus I plus 2I. Okay. So this is the real number and then this is the imaginary part. Okay. So we got the answer is 7 plus 3I. Okay. And then the same concept applies when we do subtraction. Okay. A plus BI minus C plus DI. Okay. So we have to subtract together the real number part and then the imaginary part. Okay, this is the R, this is the imaginary. So we got the answer A minus C plus B minus DI. Okay, so we can see the example here. The example 2 plus I minus 5 plus 2I. So this is the real number. Okay, and then this one is the imaginary. Okay, so 2 minus 5 and then 1 minus 2I. So we got the answer as negative 3 negative I or negative 3 minus I. Okay, and then multiplication. So how to do multiplication that involves two complex number? So we just have to expand like we normally use, like we normally do. Okay, just expand the bracket. So it become like this. So A times C plus IAD, okay, and then ICB and then I square BD. If we recall that I square, okay, is equal to negative 1, then A plus BI times C plus DI is equal to AC, okay, plus IAD plus ICB plus I square BD, this one, this part yang tadi kita dah dapat, okay, is equal to AC minus BD, okay, plus I times AD plus CB. Okay, this part that contains the imaginary number. Tapi yang ini, dia dah jadi, okay, this part, dia dah jadi negatif, dia dah jadi negatif, okay, negatif BD. Okay, kenapa negatif BD? Sebab always remember that I square is equal to negative 1. The value. Okay. Alright, so example 4. Example 4 involve multiplication. Okay. Multiplication. So 2 plus I times 3 plus 2I. So expand. You have to expand the bracket. And then you got 6 plus 4I plus 3I plus 2I square. So remember, when we got I square, we have to substitute the value as it is negative 1. So it becomes 6 plus 4I plus 3I plus 2 times negative 1. So the final answer is 4 plus 7I. Okay. And then division part. Okay, division part. You have two complex number. So you divide the first complex number with the second complex number, A plus BI over C plus DI. Alright. So when you come across this question, you have to multiply with its conjugate. So what is the conjugate? If the what is conjugate? So it is the opposite sign of the um, denominator. Okay, so if the denominator is c plus di, so its conjugate is c minus di. So both the denominator and numerator you have to multiply with the conjugate. So a plus bi times c minus di over c plus di times c minus di. And then expand the bracket, so you got c square plus d square here. Okay, for the denominator, and the upper part is AC plus BD plus CB minus ADI. Okay, so look at the example. Okay, the example 5 minus 2i over 4 plus 3i. So its conjugate is 4 minus 3i. So 5 minus 2i times 4 minus 3i over 4 plus 3i times 4 minus 3i. So expand the bracket. So you got 20 minus 15i minus 8i plus 6i square over 16 plus 9. And then the final answer will be 14 minus 23i over 25. So what I can say that the complex number, okay, we know that it is the combination of real number and imaginary number. You can do addition, subtraction, multiplication, and division for complex number. So always remember that the value of I is square root of -1, but when it is square, I square, it is equal to -1. And for I square, we always substitute its value equals to -1. And then um, okay, for multiplication, if you find that it has I square value, so you have to replace it with -1. Meanwhile, multiplication involves multiply with its conjugate for rationalize its for rationalizing the denominator. Okay, so both numerator and the denominator you have to multiply with the conjugate. Okay, the conjugate referring to the denominator value, not the numerator. So if the denominator you multiply with c minus di, so it is the same you have to do with the numerator part. Okay. So that's all for this video. So I hope that you can adapt with the new number, okay, the new parts of number in your life, which is complex number. It's not difficult, it's just an extension for for a number that contains square root -1. So it doesn't mean that when we have square root and with negative value we cannot solve it. But now you know that we can solve it by using the complex number theory. Okay, by using the imaginary number. Okay, so that's all for today. So next video we will cover the next part of complex number, which is the polar form. Okay, the polar form and Euler form. Okay, which is more challenging for you, I think. So that's all, and take care there. Okay, for everywhere you go, everywhere you do, everything you do. So just take care yourself and enjoy this video. I hope this video will be helpful for your assignment, for your individual assignment later. Okay, thank you.